Hello everyone. So I guess we will start now. So how many of you guys gave the contest, and how many questions did you solve? Okay. 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 So I guess two of them gave. Okay, all of you gave. Okay, that's good. Um. So we will be discussing four questions. So I think we will start right away. Um. Okay. So can you see my screen? Is it visible? Okay. So the first question is very simple. Um, I will go over it quickly because I guess all of you solved it. So the question is, Chef heard that there are four-leaf clovers bring good luck, so he went looking for one. In his search, Chef found n clovers in total. Out of them, exactly one was four-leaf clover, and all the others were three-leaf clovers. How many leaves did Chef collect in total across all of the clovers? So it's relatively simple. So only there is one four-leaf clover out of n clovers. So we can just, um, you know, we can just take n. We can so total number of clovers will be what, 4 plus n minus 1 into 3, right? We take one clover out, add 4, and then n minus 1 times 3. So this is relatively simple, very straightforward. So that is exactly what I did, and yeah, so it also runs and submit it. It's a correct answer. So I will directly go to the next question because I don't think we need any more discussion on this one. Okay, so this one is also relatively simple as well. The question says that we have to calculate the Hamming distance between two pairs of strings of equal length. I mean, they've actually given the definition of Hamming distance here first. So the Hamming distance is essentially if we have two strings, let's say here we have there and we have shire. So in this case, what will happen is that the Hamming distance between these two strings is essentially the number of characters, the number of positions in which they differ. So in this case, there and shire clearly differ in two positions, S, I, and E and D. So they differ in two positions, right? So this is the definition of Hamming distance. They have given the definition here of Hamming distance. Here is the actual question. Here's the actual question. So the question says is that uh, Chef first has string A of length n, and then um, uh, we have another string. So Chef has another string B, which is of length n, and m is less than n, right? But they have said that we have to find the minimum Hamming distance between B and some contiguous string of A, right? That has length n. So this question is also quite simple. Essentially, let's take this example, right? So I will also how many of you guys solved this question? Are you guys probably in div 3, right? If you're in div 3, then yeah, okay, fine, that's good. Yes, and So if you guys have gone through it, I won't go in too much detail. It's for like others who probably not have solved for later. Okay, I will go like okay. Anyways, so yeah, this was the question. So um have you guys got the question? Like there is probably one person probably did not solve this. Have you got it? Okay. Anyways, so um essentially, so yeah. So let's take these two strings. Take an example with this. So so we have storm. So essentially, we have to take contiguous substring of A that has length m. So a straightforward. So in this case, what are the contiguous substrings? So this is B. So we have to take contiguous substrings of like 3. So here we can have this option. In this case, the differences are in this place, and this place. So the Hamming distance in this scenario would be 3. Or we could take this substring. The Hamming distance in this case will be, again, this place is different. Sorry, this case is different. This place is different. It differs in this place as well. It differs in this place as well. So this is also 3. This case it will also be 3. Or we could take this string. In this case, at this place it's same. At this place it's also same, but it's different at this place. That means in this case it will be 1. So the answer for this will be the minimum Hamming distance. They have asked us to find the minimum Hamming distance. So in this case, the answer will be 1, because the minimum Hamming distance will be for this substring and this B, right? So um, so I guess you kind of understand what the approach will be. So again, there are two ways to solve this. You can solve it in an linear way, or you can just implement it in O of n into m time. That is kind of your choice, if whichever you feel comfortable with. So I did it in O of n into m during the contest. You could easily implement it in even in linear time complexity. So so the code is relatively simple. What we do is first we take the input n and m, right, and then we take two strings that they have given. Again, the input format is given here. You can check it out. It's straightforward. First we give the first they give the lengths a of a and b, and then they give the strings a b. And then what I have done is that I have taken the minimum. So sorry, like I've taken a minimum variable and initialized it with int max, and then I run a loop. I run a loop from I equals to 0 till I equals to a the size of a minus m. So I of course we do this so that we don't include garbage characters into the string that we will be creating next. So I run a loop from here to here, and then I create a string of length from I to I plus m. Do you know this like way of creating strings? Like, is it confusing, or like, do you know it already? If you know it, then I will probably not. It's actually relatively simple. All it does is from so this essentially is an iterator. This essentially is an iterator from a dot begin. So this essentially returns the iterator at position I. So we take a dot begin, then we add I, and this entire thing returns iterator to at position I, and then we take the same amount, the same iterator, and add m to it. This essentially returns an iterator after the mth letter. And in order to, construct a string using this format, you need to return take the iterator after the mth letter. So it's like you have to put the first iterator. So the string that is constructed includes the letter at the first iterator, then all of the letters, but excludes the last iterator. Excludes the last iterator. So it takes all the characters from first till last iterator minus one. Last iterator minus one. So that this is how like this is how the iterator how you can make it. And then I keep a count to calculate the Hamming distance in this case, and then run a for loop to calculate all the places in which it's different, and then add, and then calculate the minimum, and then I just print out the minimum. So I guess it's quite clear. So if you have any doubts, you can ask. Anyone having any problem? Like, is it clear? Um, I guess more or less really clear because you guys have already solved it. So also there's another linear solution. It's not that difficult to implement. So I guess we can move on to the next question. So the next question. So I guess you guys probably haven't solved it. A few haven't solved this question. Few of you, right? So I will go a little bit deeper on this one. So yeah. So the chef has array containing n positive integers. He can perform the following operation on array as many times as he likes. Choose integers L and R such that this this range is valid. Then choose a positive integer X. Then for every index I from L to R, inclusive of both, set AI equals to X. And then the cost of, they have said that the cost of this operation is essentially this. This pretty much means is the length. This is what? This is R minus L plus 1, which means that the length of the subarray that you took times the value that the X that you took. So the objective is to find the minimum cost required to make all the elements of A equal, right? So I guess you guys understand the question. Um, so do you guys understand the question? Do you guys understand the question? Yeah. Okay. So let us let us try taking this example. Like see what happens. So yeah. So we have 2, 4, 3, 2, 2. So the objective is to take this entire array, take this entire array and then convert this into um, such make this array such that it is so all the elements are equal, right? So some of our options could be we could convert it to all twos, or we could convert it to all fours, all threes, or maybe some other integer x, right? So so in this case, let us say we want um, so let's see what happens if we take this. So what is the cost for this, for doing this transformation? In this case, it will be 4, right? We changed this. We took this sub survey and then changed it, right? If we make them all of them fours, right? So in this case, we will have to take this survey and then also this one. We have to convert a total of what? 1, 3, 4. So it's the cost will be 16, right? And if we convert to all threes, then it will be 12. And so if it was some other integer x, then it will be 5 times x, right? Now it's kind of clear what the answer will be. Uh, the answer will like it's clear that it will be 4, right? And even if you like, let's say you took x equals to 1, right? In this case, it will be the answer will be 5, which is still greater than 4. So in this case, the answer is 4, right? So the thing is, in this scenario, the one which has higher frequency is winning. But the thing is, it could also, in other cases, it could also be that some other number could win, right? Because the cost is calculated as a multiplication. So it's like a length. So we have a length here, and then we multiply it by an integer x. Since it's a multiplication, it could also be that some other integer with some different length and some different maybe some value could have a higher length here and then maybe some lower integer here, and it would probably beat the one which has a higher frequency, right? So we actually won't choose the number which has higher frequency. By default, we won't choose that. So we actually have to we have to check for all of the distinct numbers that there are. That is the first thing that we need to do. Then we have to check all the distinct numbers because this cost could be minimum for any one of them because it's a multiplication, right? Times the third out. Because yeah, there is a cost. Yeah. So yeah, so the that is so his approach is more or less correct. And I with him. Uh, so we so yeah, we have to loop through all the distinct elements, and then we have to calculate for each of them what the thing is, the cost is, and then we have to find the minimum out of all of those, right? We have to find the minimum. Now there is one small catch to this. There is one small catch to this is that uh, you I guess it's better to like just take an example. Right? So let's say we take something like 10, 10, 30, 40, 40, 2, 2, right? So what are our options here? We can convert the entire 10, 30, 40, or 2, right? So if we convert the entire 10, it will be what? 60. The cost will be 60. We convert the entire at 30, then it will be 5 to 7 to 210. 210, yeah. We convert the entire at 40, then the value will be 240, right? And let's say we convert the entire at 2. In this case, the value will be 10, right? So it looks like this will be the answer. But can you guys say which one is the actual answer? What value we should actually take in this case? What value should we actually take in this case? Can you guys say? In this case, if you take 1, the answer will be for 8, right? Yeah. So the answer will be 8. So in some scenarios, you can see that taking 1 and completely changing the entire array to that 1 gives us the minimum cost. So that means we could essentially what we have to do is we will try all of the for all the frequency items, and then calculate all of the costs and find the minimum, and then also check if it is lesser than if we took 1 as x. So if we took 1 as x, so if we took 1 as x, so then the cost will directly be the size of the array, right? If 1 is not among the 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 elements, 1 is not among the elements, then uh, n will be the size. So that is exactly what I did. So I have taken, so according to the input, first they give us n size of the array, and then the array elements. Of course, the test cases are there. So here I have handled it, and then I've called the function for each test case, solve, right? So we have, so first we have the size, we take the size, and then I directly make the map, directly make the frequency table, right? We take the map and then take the integer, take the integer, and then make the frequency table. I guess that is straightforward, right? And then what I do is, I guess there is no problem in making the frequency table, right? Is there a problem in frequency table? So I guess it's straightforward. So yeah. So anyways, so this is how you create the frequency table, and then we take the minimum, take a minimum variable, and then I iterate through the frequency table, and then again this is the cost of each iteration of each item, right? And I take the minimum, and then finally I take the minimum of either, if it is either the case, like if if you take 1 as uh, the element that we want to switch to, or we want uh, and compare it with the minimum that we already got from here, right? And this, and we print out this, yeah. So again, this You solve the question. Yeah, not a correct answer. So so are there any uh, doubts? So the next problem will be taken by Shiv. So yeah.
Hello everyone. So let's take up the next problem. So this problem is named as amphibian escape. Uh, so those who solved it and those who tried, you can write your approaches in the chat box, and I'll look into it after reading the question. So what we have here is that chef is building a robot frog, which he would like to be able to climb out of a well. And the well has basically 8 units of height, and initially the frog is at the bottom. Okay. So what we basically have is that A is the jumping power of the frog, and B is the slipperiness of the well's wall. So what happens in every second is that the frog will jump A units from his current position, and if his final position becomes greater than or equals to H, so then our process stops, and we consider that the frog is out of the well. And if that is not the case, that is if the final position is less than H, then what happens then? He slips down to a distance of B. He slips down by a distance of B. However, we are also mentioned here that uh, the distance will the distance of the frog will never be negative. It will be either 0 or x minus b, like whichever is maximum. Okay. Uh, so basically, what we have to do is that we have to count the number of pairs A and B such that for all A from 1 to n and for all B from 1 to n, uh, we have to find A and B such that their values are within 1 to n, and using those A's and B's, the frog will take at max of k seconds to jump out of the well. So in order to do this, like what we basically have to do is that we'll be given three numbers n, h, and k, n, k, and h, and then we will have to count the number of pairs, right? So let's take a test case. Let's consider this case, okay? So here n is 4, k is 4, and h is 4 as well. So like if you think about this, what we basically have is that n is equals to 5, and the height of the well is 4, and we have to complete we have to come out of the well in 4 seconds, right? So now let us iterate over the possible values of a's and b's, and let's see what happens. So we know that a and b can be between 1 to n. So first let us assume that a is equals to 1. So what will happen if a is equals to 1? Like whatever value of b, like whatever be the value of b, when we start at position x equals to 0, and we make one we jump one step, right? So whatever be the value of b, b will be at least 1, right? B cannot be less than 1, so b will also start with 1 at least. So in this case, let us I am at a position 0, and then I make a jump to position 1, right? Like A is 1, so I jump to position 1. And after that, what will happen? Since this is less than 4, so I will slip down and slip down by 1 step. So again, my final position becomes 0, right? And this will keep on continuing. I will go 1 step and then I will slip down again. I will go 1 step and then I will slip down again. And let us say if like b's value was greater, okay, b was say 2 or 3 or whatever, even in that case I would never be able to reach any step further than 1, right? So we know one thing, that for any set of given values, we will never have a solution if a is equals to 1, right? So we can just exclude this case. So now let us think about what will happen when a equals 2, right? So if a equals 2 and initial value of b1, okay, so what will happen? Initially I am at 0, then I will go to 2, right? And after going to 2, what will happen? I will slip down and I will slip down by 1 position, so I will be at 1 finally, right? And next what will happen? So this was in first second. So then what will happen? Like since I can jump 2 levels, so from 1 I will be jumping to 3, and after jumping to 3 I will be put down by like I will slip down 1 step, so my final position will be 2. This is at time 2 seconds, and this will go on like this. I will be at 3 at 3 seconds. Now you should pay attention that, see, our value of k is 4 and our value of h is 4 as well, right? So if k is 4, that means ki we have 4 seconds to come out of the well, and h is 4, that means if at any time and at any moment if my position is more than 4, then I am considered out of the well, right? So now I'm at time equals to 3. So if I just jump to 5, right, then I'm out of the well. Then in this case I will not slip anymore, right? Since I'm out of the well, I will not slip anymore. Or I can just take 1 step also, but since a is equals to 2, so I am bound to take 2 steps, right? But even if I had 1 step here, it would have worked and I would be out of the well, right? But if a equals to 2 and we consider ki b is also equals to 2, then what will happen? Like of course, like I will take 1 step and I will back to 0. I will go to 2 and then I will back to 0, right? So I will go to 2 and then I will again slip back to 0. So I would never have a value, like I would never be able to reach the top of the well, and so on for any other value of b which will be greater than 2. So what we found was that if a is equals to 2, b equals to 1 is the only answer, right? And now let us consider that the value of a is equals to 3. Okay, so now b starts with 1. So initially what will happen? I'm at 0, and then I will make a jump to position 3 and then I will slip down by 1 position. So I will be at 2, right? And now if I jump to 3 position, what will be my position? My position will be 5. And remember that our h was 4. So I am out of the well. Like within 2 seconds, I will be out of the well, right? So on and on like this. Even for b equals to 2, you can like work it out and you will find that it works. And for b equals to 3, like it will be the same case again, right? No, sorry, uh, like if b is equals to 2, it will work. But if like b is equals to 3, in that case what will happen? It will be again a circle, like from 0 you go to 3 and then you slip back to 0 again. So like this will be a circle and you won't be able to sort it out. So we got value for b equals to 1 and b equals to 2. These two work out for us in case a is equals to 3. So now if we consider key a is equals to 4, right? So if you remember that our value of h was 4. So in this case, what I can say, like if I make just one jump, okay, just in one jump, I will be at position 4. So I'm out of the well in one jump, right? So regardless of the value of b, I will be able to make this, right? So for a equals to 4, all values of b will suffice. All values of b. So basically b can be anything from 1 to n, right? B can be anything from 1 to n, and this value will suffice. And for a equals to 5 as well, right? So what we can note from here is that for any case, if we have a equals to 1, there will be no answer. And if a is greater than or equal to our like our the given value of h, okay, so in that case any value of b will suffice. That is, if a is greater than h, then we can add, let us say this is our answer variable, we can simply add n to our answer, right? Because all n possible values of b will suffice for any value of a greater than or equal to the height of the well, because I can come out of the well in just one jump. Okay, so in that case the slipperiness would not matter. So these are the two key aspects that we have learned from here. Okay, so now comes the case, what will happen if a is in between 1 and h? If a is greater than 1 and a is less than h. So what will happen in this scenario, right? So this is what we have to figure out, and rest of the other parts are sorted. We have seen that. So what we can do is that, see, what we are given is that we have to come out of the well within k time, right? Within k seconds, we have to come out of the well. So in that case, what we can do, like we can define something like climbs per second, like in 1 second how much does the frog is able to climb, right? So we know what, in every second what will happen, the frog will jump by a position and then he will slip down by b, right? He will jump by a and he will slip by b. So what is the total increment in his, like in any second, what is the total increment? A minus b, right? But this a minus b will be in which condition? He is not out of the well. Okay, so let us say for any given value of a, if I have any particular value of a and the height of my well is h, okay, and I have to come out in k amount of time. So what I can say is that if at time equals to k minus 1, if at time k minus 1 my current position, okay, my current position is at least h minus a, okay, I should write it greater than or equal to. So if my current position at time k minus 1 is greater than or equal to h minus a, then I can surely in the last remaining second I can surely jump out of the well, right? So this is what we have to figure out. We have to figure out for a given value of a, what can be the maximum value of b such that at time k minus 1 I can reach up to h minus a height. Okay, so this is the, like the basic crux of the question. So what will be our approach towards solving this question is that we can iterate over the values of a from 1 to n. If the value of a is 1, we know no answer is possible. Okay, if the value of a is greater than or equal to h, we know that we can simply add n to our answer because all values of b will be satisfied. But for all other cases, we need to figure this out. Okay, what is the maximum value of b till which, which if I use, I will be at a position greater than h minus a at time k minus 1. So this is what we have to figure out. So how will we figure this out? So as I was discussing here, he at each second when he is inside the well, his total change in position is a minus b, right? So his change in position is a minus b. So in each second he's traversing this much distance, right? So if I figure it out, key, if h minus a is my distance, right, and k minus 1 is my time. So whatever comes out here, okay, whatever is the answer here is the amount of climb or amount of increment that I have to make in a second, right? So I will define this as CPS. So what is CPS? CPS is basically climbs per second. Okay, so this is what we have to do. So at so like in each second I must be able to make at least this much of climb, right? So what I can say is that the minimum value of a minus b must be equal to this value, right? So from here I can easily get my value of b, and I can just simply add that value of b to my answer. So that is what I have done here in my code, right? What I have done is that I've taken the inputs, initialized answer to 0, then looped over 1, like I from 1 to n. Okay, if I is greater than equals to h, I'm simply adding n to my answer. If not, then I'm defining here a new height. Okay, new h. So which is equals to h minus I, right? So what is I here? I here is the current value of a, right? So this is just exactly what we have done here, h minus a by k minus 1. So what I'm defining CPS is new h by k minus 1, and like this part is because we need the ceiling function, right? So if the modulo is unequal to 0, I'm incrementing CPS by 1. So this is just to get the ceiling, like the seal value of the CPS, right? And then I'm adding like the maximum 0 and I minus CPS. So basically what I need is key, like if the climb per second is more than my a, then of course I cannot do it, right? If this goes negative, if this part goes negative, then I will be adding 0 to my answer. Otherwise I'll be adding this, and then I'm simply like printing the answer. And so like if we submit this, so the code runs and gives me correct answer. So I hope this question was clear to all of you. If you guys are having any doubts, you can ask now, or maybe you can like go through the video later and like ask the doubts in your respective mentorship groups. So like this was the last question for today. And acha, I minus CPS part. Okay. So just look at it. Acha, let's explain the whiteboard. So see, what is CPS? CPS is h minus a by k minus 1, right? So this is the minimum amount of steps, the minimum amount of increment that should be there in my position, right? So a minus b, this is the increment that I have in every second. Okay, so and CPS is the least value of that thing which I must have. Okay, CPS is the least value of a minus b that should be there, right? So what I need to do is that I need to find out what should be the maximum value of b that will allow me to have this, right? The maximum value of b that will allow me to like have this particular value of CPS. So if I equate this with CPS, right, and like if I just change sides, what will I get? I will get B equals to A minus CPS, right? So this is what I have written here. Like this A actually represents this I here. Like we are iterating over the possible values of I, right? And I stands like represents our value of A in this part. We can also take an example so that like you can understand it better. So let us assume, let us take this third test case. So 26 and 18, 6, 18. So this is N, N, K, and H. This is K, and this is H. Okay, so let us say our possible pair of A and B is 7 comma 5. Acha, see, now we can also calculate it from here. Ki what should be the value of, like if A is equals to 7, what should be the maximum value of B, right? So if A is 7, from our formula, what we get? Nu H minus I by K minus 1, right? We get this from our formula. Uh, so this is 11 by 5. And if we take the ceiling of this, if we take the ceiling of this, 11 by 5, so that is 2 point something, so this will turn out to be 3, right? uh, okay, you have understood it. Still, let me go through my example, so that will make your understanding better. So now why am I taking answer is plus equals to I minus CPS. So see this, this is my CPS, right? So what does this represent? This represent that I can go up to 7 minus 3, that up to 7 minus 3, which is equals to 4. Like for up to this value of B, I will be able to make it out, right? So if we consider 7 comma 4, I will be starting out at 0. What will be my first value? Like I make it up to 7, then I slip down, so I will be at 3, right? See, how much did I make it up in 1 second? 3 steps, right? And then again, let's say I make it up to 10 and then I slip down, so it will be 6. Then it will go on 9, and then it will go on 12, and from 12, so how many seconds? 1, 2, 3, 4, and now 12 plus 7, that will be 19. That will be more than my height. So at 19 I am out of the well. And how much time did it took? It took 5 seconds. But if I had, let us say, the value of slipperiness as 5, in that case I'll be like, let us say, from 0, I'll be making it to 7 and then slipping down by 5 steps to 2. Then I'll be at 4. Then I'll be at 6. Then at 8. Then at 10. And then at 12. And after this I'll be able to make it to 19 and get out of the well. So you can see that it takes more time than that. Here was 5, so this is the 6th second, but the value of k was 6 and I am making it out at the 7th second, right? So this is why we are like I minus CPS basically gives me the maximum value of B that I can use, right? So that is why I am writing that as this. And like in case it becomes negative, so to handle that edge case, I am adding this maximum of 0 comma I minus CPS part. So I hope this is clear to all of you, and thank you for joining this meet. So I hope all of you guys have benefited from our discussion. And like any further doubts, like our groups will always be open to you. So keep posting your doubts if you get them, and we'll be trying to solve them as fast as we can. Thank you, everyone.